All right, so for this last unit review, here we're applying the properties of exponents. The first thing we're going to do is essentially like distribute this exponent to everything on the inside of the parentheses here. When you raise a power to a power, you multiply it. So I get y to the 8th, and then I end up with 2 squared, x to the 6th, y to the 6th. So at this point, I've got y to the 8th all over, and then 2 squared is 4, x to the 6th, y to the 6th. And I have y's on top and bottom, so I have to simplify those. I have more y's on top, so I'm going to have y's left on top. I have 2 more y's on top, so I end up with y squared all over 4x to the power of 6. All right, next one. So again, we got to go distribute that power. I get 2yx squared all over 2 squared, y to the 8th. So for my 2's, let's see, I get this, yx squared, and I get 4, y to the 8th. All right, so 2 over 4 simplifies to 1/2. So I end up with just a 2 in the denominator. My y's, I have more y's on the bottom, so I have 7 more, so I get a y to the 7th in the denominator, and then all I have left up top is an x squared. All right, these we got to break down. Square root or cube root of 256. So we have to use perfect cubes to simplify this. Let's see, I think that would be what, 60, yeah, so 64 times 4. Whoops. And I got to break these down to things I can divide by 3. X squared I can't break down at all. Y to the 6 I actually can already divide by 3. So this 64, the cube root of it is 4. This 4 has got to stay in because I cannot cube root it. This x squared has got to stay in because I cannot cube root it. And y to the 6 I divide by 3. Comes out as y squared. So on the inside I have cube root of 4x squared. All right, this one, we got to break down the 375. That's going to be 125 as my perfect cube there. So I get 125 times 3. I break it down into x cubed times x, and then y to the 6 times y. The reason I do this is I want to break it down into numbers that I can divide by 3. The cube root of 125 is 5. 3 stays in. Cube root of x cubed is x. This x stays in. Cube root of x to the 6th is y squared. This y stays in. So I've got cube root of 3xy. And that is my answer there. All right. Let's see here. Now we got to go ahead and get the square root by itself. So I'm going to add x to both sides. So I get the square root of 32 minus 7x is equal to x minus 6. Then I'm going to square both sides. So I get 32 minus 7x is equal to x minus 6 squared. Now this, we're going to write twice. So I get x minus 6 times x minus 6. And then I can go FOIL that out. And I get x squared minus 6x minus 6x plus 36. So at this point, I have 32 minus 7x is equal to x squared minus 12x plus 36. I need to get it set equal to 0. I subtract 32 from both sides. I add 7x to both sides. And I get that 0 is equal to x squared minus 5x plus 4. So I factor this. I get x minus 4, x minus 1. I set these equal to 0. So as my possible solutions, I get x equals 4 and x equals 1. Now, before I go and circle these and say I'm good to go, I need to go plug them in and make sure that they give me good answers here. So I'm going to say I plug a negative in here, so I get negative 4 plus the square root of 32 minus 7 times... All right, so I plug in the 4. This part I can just like plug into my calculator. So let's see, we end up with negative 4 plus the square root of 32 minus 7 times 4. And I get that negative 2 is equal to negative 6, which is false. So this 4 is actually a bad answer. Now I got to go check my 1. So I get minus 1 plus the square root of 32 minus 7 times 1 equals negative 6. I can go plug this into my calculator. And I end up with 4 equals negative 6, which is also bad. So when both of these are bad, you actually would put no solution. All right, now I got to go solve this one. Same exact thing. I square both sides. So I get k minus 2 times k minus 2 equals 3k minus 2. When I FOIL this out, I get k squared minus 4k plus 4 equals 3k minus 2. I subtract 3k from both sides. I add 2 to both sides. So I get k squared minus 7k plus 6 equals 0. I factor this. I get x minus 6 times x minus 1 equals 0. So for my possible solutions, I get 6 and 1. I need to go check them. So I get 6 minus 2 is equal to the square root of 3 times 2 minus 2. So I get 4 equals the square root of, let's see, what is that? 6 minus 2 is 4. So I get that 4 is equal to 2, which, let's see. Oh, what did I do wrong here? I plugged in a 2 instead of a 6. I'm like, this is not right. So I need to put a 6 in here, my bad. All right, so then I get 4, and then I get square root of 16, so I get 4 equals 4. So 6 is a good answer. I need to go check my 1, so I do 1 minus 2 is equal to the square root of 3 times 1 minus 2, so I get negative 1 is equal to the square root of 3 minus 2, so negative 1 is equal to the square root of 1, which is false because negative 1 does not equal 1, so that's a bad solution. So my only good solution here is 6. All right, I'm just going to do one of each of these. So this one, we have to multiply by the conjugate. I'm going to do 4 minus the square root of 3. No, I'm not. Sorry. We got to do the one on the bottom. So 4 minus the square root of 2. 4 minus the square root of 2. I'm going to FOIL this on top. So I get 16 minus 4 root 2. And then plus 4 root 3. And there I get a minus square root of 6. And then in the denominator here, let's see, I get 16 minus 4 root 2 plus 4 root 2, and then minus square root of 4. So in the numerator, I actually can't simplify this at all. So I get 16 minus 4 root 2 plus 4 root 3 minus root 6 all over, and these guys cancel, and I get 16 minus 2, which gives me 14, and this is my final answer here. All right, this last bit here, this is a shrink by a factor of 3/5. This is left 2 and down